Okay, I just want to point out something before I share with you the video, right? The whole video. Now, the first thing is this, you must take note that every light bulb down here, right? Every light bulb, they actually have some resistance. What do I mean by having some resistance? Anything that have resistance will slow down the flow of your electrical charges. The red balls down here that you see will represent the electrical charges. Now this is a battery, right? This is a battery. The battery will provide a force, now a force to push the charges around the circuit. The force depends on the voltage of the battery, right? It depends on the voltage. Higher the voltage, the bigger the force. So you have more power it will have more strength to push the electrical charges around in a faster manner, right? You will push it faster. All right. How about current? When we talk about current, high current means what? Now, current is a measure of how fast your charges flow, right? If I want to say current that passes through the light bulb, for example, right? Current that passes through the light bulb is a measure of how fast all these charges flows through the light bulb, right? The faster they flow through, the more they flow through per second, the more charges flowing through the light bulb per second, the higher the current. All right. Okay. Now let's let me move on to the other one. All right. 07. Okay, the bulb down here, can we take a look at the bulb down here? This bulb down here, it has got two terminals. Why? Okay, terminals. Let me. Now, this is a symbol of your light bulb, right? This is a symbol of light bulb. One terminal, two terminal. The first terminal, second terminal. Now, current will only flow through if there is a different, there is a potential difference. We call it, there is a voltage, right? Take a look at this. The first terminal down here, you can take it as the side. See, this is the wire, wire connected to the side. The second one can be taken as this, right? The bottom. So as you can see, there is a difference in potential. There is a difference in force. One side is higher, the other side is lower, right? So that's when your charges will flow. All right. Okay. Let's move on. 127. Okay. Now you can see that just now I only have one light bulb. Now you have three light bulbs connected in this manner. Now, this type of connection we call them parallel connection. Why is it called parallel connection? Right, there are actually two types of connection. One is series, the other one is parallel. It is called parallel because the voltage across the three light bulbs, they are the same. Why is it the same? Now the two terminals, see, first terminal, second terminal, first terminal, second terminal, second terminal. Now the first terminal of all the three light bulbs, they are connected together. Can you see? They are connected together. The second terminal is also connected together. All right. So this type of connection we call parallel connection. They are connected to the battery, right? The same terminal, right? All connected to one end of the battery. The other terminal all connected to the other end, which is why the same voltage. You look at the voltage, voltage across all the three light bulbs, they are the same. What does that mean? Just now we say that the voltage will determine how fast the charges get pushed right around the circuit. So if the voltage between the two terminals down here, they are the same, that means the electrical charges will flow through the light bulbs at the same rate, right? The charges will flow through all the three bulbs at the same rate, which means the same current will flow through, the same current flow through all the three light bulbs. All right, this current flowing in here equals to this one, it will also be equal to this one. All right, how about the current flowing out of the battery? Now you see current flowing out of the battery down here, flow until here, it will split. Later you look at a video, you will see, oops, right, you will see that the current flowing here, it gets split into 1, 2 and 3, right? It gets split into 3 parts, right? Which means that this current flowing out of the battery, right, is equals to the sum of these 3 current, 1, 2, 3, right? 1, 2 and 3, right? Sum of the current flowing through each of the light bulb will be equals to the current flowing out of the battery. Now, the advantage of connecting it this way, now this type of connection you will find it where? At home, right? Your toilet, this one maybe your bedroom, your living room, all right? So you can switch on the toilet light, right? Without switching on your living room or your bedroom, all right? If in the event that one of the light blows, that means this is faulty, it will not affect the other two, all right? And then they will have the same brightness because they are all connected with the same voltage, all right? So this is the advantage of parallel connection. But however, that being the case, because the current flowing out of the battery is very high, right? The more light bulb you connect, the higher the current will be. All right, the battery will drain out faster. Now this is the circuit diagram, right? Now you have this battery down here, right? Let me forward it. Now battery on the left, right? Battery on the left, connected in parallel, right? The 3 batteries down here, the 3 bulbs down here with 3 switches, right? So this will be the circuit diagram. All right. Okay. One more last thing before I end it. Okay. Okay. Let's move on to the other one first before I come back here. Okay. When you look at towards the end of the video, you will see that there is this series connection down here, right? This series connection. The 3 light bulbs are connected in series. So what happens is this, when you have light bulbs connected in series, all right, as I say just now, every light bulb presents some resistance. That means will slow down the electrical charges. Oh, so the force down here, the force down here would have to try to push your charges to overcome the resistance down here, followed by the resistance down here, followed by the resistance down here, which is why it will slow down, right? It will slow down the flow, right? It will slow down the flow of the electrical charges, which means that if I connect it this way in series, right, in series, a lower current will flow through the 3 light bulbs. Now the same current, but which is lower, right? The same current will flow through 1, 2, 3, right? The 3 light bulb all will have the same current, but then however, it will be a lower current, right? If I take away 2, right, this one will become brighter, right? The more light bulbs I connect, the lower the current, right? The dimmer the light bulb will be. All right, that's how it works. Okay, let me go back to this one to show you something. Okay, you can see that the voltage down here, the voltage, one battery, same battery, the voltage is shared among the three light bulbs, right? The 3 light bulbs. So if you have voltage shared among the 3 light bulbs, that means each of the light bulb will now only have 1/3 of the voltage. Alright, voltage is the force that push the electrical charges around the circuit. Alright, when you have a lower voltage, of course the electrical charges will slow down. The flow of electrical charges slow down. That means you will have a lower current, right? Lower current will flow. Now, we take a look at this. There is a switch connected in parallel to the second light bulb down here. Now, can I just show you the circuit diagram? All right. It is actually connected in this manner. Now, ignore this part. We ignore this part. Right. Now, we have a battery connected in series with the 3 light bulbs. There is a switch down here. Alright, so if I close the switch down here, what will happen? The current will flow in this manner. Right. Alright, current will flow through the first light bulb. It will not flow through the second light bulb, but it will flow through the third light bulb. Now, it will flow through like that. Why is it that the current choose to flow through this manner? It is because now there I told you that the light bulb has certain resistance, right? Have certain resistance. When the current comes here, when the current flows until here, it sees a certain resistance down here. Right. I must well take this easier path. Right. There is no resistance. The resistance of this path is very much lower than this, which is why current will move here. Right. It will take the path of least resistance. Alright. Okay, now you can watch the entire video, keeping all this in mind. Right. Enjoy the video.